Hi, everybody. This is Joanne with Read Science, Science Status on Twitter. And I am joined, of course, as always, by my wonderful co-host, Jeff Schomeyer, sitting in Washington, D.C. I guess we can call this episode the Midwest episode because our guest hails from the Midwest. She is sitting in Minnesota right now. I'm in Illinois, but she used to be from Illinois. Anyway, we are here with Nancy Atkinson. Say hi to our guest, Nancy.
Hi, everybody. Glad to be with you. Thanks so much for inviting me on.
Yeah, and we're so glad to have you on because you've written a really interesting book that I was really enjoying. So it's called Incredible Stories from Space, a behind-the-scenes look at the missions changing our view of the cosmos. And I definitely will get to talking about the contents of the book, which missions you cover. But you guys, this is really good if you ever want an overview of what we've got out in the skies right now, the unmanned space missions, and if you want to learn about the people behind the missions. So I really enjoyed it, actually. I felt like, I know, so my thing is I know about all these missions, but I don't know all the details. So this is the perfect book to catch you up on that. So let me introduce properly, read Nancy's bio so you guys know who she is. I have known about her for years, ever since sort of the accessibility of space news has been increasing. So her name is on many bylines. She is currently Universe Today's contributing editor. She has worked as the senior editor there, and and as a lead writer. She has worked with Astronomy Cast and 365 Days of Astronomy. She's the author of this new book, Incredible Stories from Space. And she is also a NASA JPL Solar System Ambassador, which I would love to hear more about too. So welcome, Nancy.
Thanks so much for having me on, Joanne and Jeff. I'm happy to be with you.
Thank you.
Oh, it's great fun, and we enjoyed your book. There have been so many interesting robotic, I'm sort of avoiding the word manned, but interesting,
unmanned.
Yeah, robotic, non-human missions, and a lot of them have passed through the news, but it's hard to keep them straight. And I want to start with one that, I don't know, struck me as more incredible, and I was thinking about all the people we've talked to on Read Science who can give us history of amazing things that have happened in science in just the last 20 or 30 years. Someplace along the way when you were writing about the Kepler mission, you said less than 30 years ago, astronomers weren't sure of any other planets outside our own system. Less than 30 years ago. That was like after I finished graduate school. Then in another place, you said around the mid-90s, scientists weren't convinced that exoplanets were a thing. Yes. And then the first confirmed discovery of an exoplanet came in 1994 using giant telescopes on Earth. And then you pointed out that by 2000, we knew an amazing 50 exoplanets existed. And then the pace picked up. And now I want you to astound us with what Kepler did and how many planets we know about. It's phenomenal.
Yeah, the Kepler mission, I think, just really changed the whole landscape of what we knew about other planets orbiting distant stars, other stars. As I said, yeah, it's been a short time period, or as you said, it's been a short time period that we've come to know all about the possibility of planets orbiting other stars.
You quoted Thomas Barclay, who is a mission scientist.
Yes, he works.
Okay, who said, I think everybody was astounded by just how easy it was to find planets in the Kepler data. And you noted that there were 750 candidate planets in the first 43 days that they were looking.
Right. I think, yeah, he said that everybody was astounded. I know as a journalist and as a space fan and follower that I was astounded just every time there was a press release coming out from the Kepler team. Here were a couple hundred or 1,000 planetary candidates, and just, yeah, it seemed like there was just an abundance of planets out there, and we were finding, and Kepler was finding them so easily, and it was looking at just a kind of a small spot in the sky. really, and the
Yeah.
stars were kind of far away. So it was just really amazing how easily or how quickly this incredible spacecraft found these planets.
And I thought that was a really interesting point that I was quite aware of, I think, when I started hearing about Kepler. But you quoted here, you're quoting Natalie Batalha, that Kepler is a statistical mission. And what they're doing is they're not looking at all of the sky and trying to find all the planets out there. They said, let's look at a small piece of sky very closely that appears to have not a lot going on in it and see what we can find. That's where they're looking, right? And where they're finding these astounding numbers of things in a little dark piece of sky that other telescopes look at and say, there's not much going on there.
Yeah. So it's just like when pollsters do a survey of a small number of people to get a general idea of what the entire population is thinking or feeling on a certain topic. You look at a small spot in the sky and get the kind of general idea of how many stars have planets orbiting them. And before Kepler, we had no idea. Does every star have planets? Just a few? Well, now we know that every star has at least one planet, and almost all of them that we can find have multiple planets. So that's just incredibly exciting. But we're also finding that the solar systems out there are very different from our own. One of the most common type of planets out there is one that we don't have in our solar system, or at least that we haven't found yet. There's a chance that the hypothetical Planet 9 that Mike Brown and his compatriots are theorizing is out there might be, but it's a planet that's in between the size of Earth and Neptune. So kind of a super Earth is what they call them.
Predominantly rocky or more gassy, or?
Well, early on in finding planets, of course, the bigger they are, the easier they are to find. So early on, the planets that we found were primarily gas giant planets because they're big, and also the ones close to their star are easiest for us to see at this time with the current technology. But now they are finding, I think it was exciting, and I can't remember what year this was. It was within the first couple of years of the Kepler mission that they found the first and verified the first true rocky planet and or rocky Earth-sized world. So that was the big excitement. That was kind of their goal, their main goal of finding an Earth-sized rocky planet.
It seemed like the way that they're doing this, of looking intently at this small part of space, reminded me of the Hubble deep field and ultra deep field things, where they turned the Hubble to an empty part of space, so-called empty, and collected light for weeks altogether. And there's just, it's hard to keep saying astounding, but it's like there's just way more galaxies, let alone stars, than we ever could have imagined, I think.
Right. Yeah. That, I also read about the Hubble mission too, and that is truly the Hubble deep fields and ultra deep fields are, I think, my favorite, at least. And whether people want to say that's the most astounding thing that Hubble has found is just staring at what they thought was an empty piece of sky, the size of a grain of sand held at arm's length. And it's just full of galaxies beyond galaxies beyond galaxies. And it's just mind-blowing is the word that I think of.
This is a bit tangential before I let Joanne say anything. But there's an important point here about NASA and all of these missions, which is if people want to see and haven't seen the Hubble Deep Field, they can find it on the internet. If they want to find Kepler data or Cassini data or any of these other mission data, they can find it readily on the internet, because I don't think there's any agency as committed to sharing discovery and excitement with the public as NASA is.
Yeah, I would agree. And especially in the past few years, they've gotten so good at their social media that, and they're inviting the general public to participate in these, they used to call them tweet ups, but now they're NASA socials, where they actually invite the general public to attend launches or to attend press conferences and actually be, it's not just the journalists anymore that have the access like this. And I think it's so great because they're retweeting the general public's take on a launch or a press conference or that kind of thing.
And Kepler particularly has had citizen science opportunities, right, with looking at things and helping to identify candidates for further exploration by the mission scientists and the project scientists, right?
Right. Yeah. There, some of the Kepler data has been made available through the Zooniverse universe of all these different citizen science projects. But a lot of the missions actually have a citizen science component, and that too really involves the general public. You don't have to be have a PhD to actually make huge contributions to some of these NASA missions, which is so exciting, especially all of us nerds that hang out online. It's just like we can actually make contributions to a NASA mission. That's really exciting.
It is absolutely fascinating. I remember many years ago, maybe less than 10, but there was a 14-year-old girl who managed to make a significant discovery. I can't even remember what it is, but I remember it was big news. Like, here's this 14-year-old girl. And so space is inherently fascinating to people. I think the space and the weather, there's something really, really interesting about these two topics that, non-scientists can really, appreciate and get into and things like that. So what is your take on that, being, a journalist in the field of space exploration and astronomy?
The public's involvement or the public's interest?
The public's interest, yeah.
Yeah. Well, on Universe Today, the primary website that I write for, and I've had the honor and privilege of writing for since 2004, we've had a great interaction with our readers, and that's part of why I enjoy writing for Universe Today so much, is that we've had a great comment section and people commenting on articles and a great discussion. There used to be a forum, the Bad Astronomy Universe Today forum, that people would just have these great discussions about the science, and these are people that actually go back after they read our article. They'll go and read the science paper that we've been writing about, and really intelligent discussions. So maybe on Facebook or YouTube you have a little less intelligent discussions, but still people are excited to discuss the science and the findings and the great images that are coming back from missions like Cassini and Juno, and how involved the public is in actually processing some of these images. It has been really fun to follow lately, especially the Cassini images and the Juno mission to Jupiter. Actually, their camera is completely accessible to the public to process their images. When I was doing the interviews for the book on this mission on Juno, they were telling me, when we put our mission plan together, all of the data that we wanted to get didn't really include an optical, visible light camera, but they thought, well, we're going to Jupiter, we should really bring a camera along. So they decided to make it a completely public camera. The members of the public can choose what images they want to take or where they want to take pictures on Jupiter. And then all of the processing is done by citizen scientists who just have this love of taking the raw data that's coming in. NASA makes it available as soon as it gets to Earth, and people jump on this data and process it. And the images have been absolutely incredible.
That's amazing. I remember there's a famous story about one of the missions, I should know, one of the rover missions to Mars that Carl Sagan was involved with, and there wasn't going to be a camera And he sort of said, well, wait a minute, if there was something interesting there, wouldn't we want a picture of it?
Right. Yeah,
So
the same thing with like, was it, one of the first manned missions, like John Glenn insisted that he should bring a camera along on his, first orbital mission of the Earth. And they were like, well, we don't know, it's, if that's a good idea, but it was like, no, we need to share this.
Right.
And I think that's.
I think like all these images really engage the public. And actually, I wanted to talk about images in your book. Now, I know for a fact, I mean, there's color images and, of course, these beautiful images from, we've got pictures of people, we got pictures from the missions. And so this is put on very high quality paper. It's very nice. So, but the good, what I know about photos and books is they can often be very expensive, but thanks to NASA and everything sort of free to the public, right? This really brings down the costs, right?
Yeah, right.
Yeah,
that's what I was in negotiations with the publisher. I was saying, well, we need to include a lot of pictures because those pictures really tell the story of what these missions are doing and finding. And they said, well, how can we do that? I said, well, all of NASA's images are freely available. They're public domain. So that's, that was wonderful. And I was able to include over 240 images in the book. And that was fun to be able to pick that many images. I mean, it was hard to actually limit it to that many because there's so many great images from the different spacecraft out there.
Yeah, it's really amazing. And I do want to let people know, actually, as nice as this book is, this comes out really, really nice in the electronic book version too.
Yeah, thanks. I'm glad you enjoyed that electronically as well. But yeah, I was really pleased with the quality of the paper that the publisher used, and they did a really good job of making sure that the color was color came out really well.
Yeah. Oh no, that's definitely true. I really, really enjoyed these. So teachers hopefully know this by now, but anybody, you can go to NASA and get all sorts of resources, including these beautiful images and data, and they have their extension for education, right? So.
Yes, right. Yeah. So a lot of great resources for teachers and anybody interested in space exploration. Just go to NASA's website and you can find them all.
But what I like about having a book like this is that, everything is told in one place. Because sometimes NASA's website, it's big and you'll be redirected here and there. So this is great because if you're interested in these missions. So if everyone will humor me, I just want to read your table of contents. And then I want to know, how did you choose what order to put them in? Okay, so let me read this. So we've got an introduction, but we'll start here. So she starts with Unlocking Pluto's Secrets, New Horizons. That's Alan Stern's project. That was so exciting a couple years ago. Roving Mars with Curiosity, which of course you bring up other rovers. Can't just talk about one without the others. Changing Everything, the remarkable Hubble Space Telescope. Of course, that was incredible. Traveling Between Two Worlds, Dawn. Frankly, I will tell you, this one I didn't know that much about, so I was happy to read about it. Hunting for Planets, Kepler and the Search for Other Worlds, which is, of course, we're looking for exoplanets in addition to everything else. Unveiling Secrets of a Ringed World and Its Icy Moons, Cassini Huygens. Now, unless I should say that differently. I say Huygens.
Okay.
Huygens, is it right?
Huygens is how I pronounce it.
Then you were probably right. Downloading the Sun 24/7, the Solar Dynamics Observatory, which I've always had a fascination with. Rising to the Occasion, the Mars Reconnaissance Orbiter and HiRISE. And Shooting the Moon, the Lunar Reconnaissance Orbiter. And then you talk about some missions and discoveries to watch. And of course, ask the important question of why we should explore space. So my first question, this is so for the benefit of people watching, this is what's in the book. So how did you choose the order?
Oh, the order, I guess I chose to do the New Horizons mission first because that, when I started writing the book, that mission at just like about 6 months before that was when they did the flyby of Pluto. So that one was kind of fresh on my mind, and it was all the data that was just coming back from the mission and from the flyby of the Pluto system. And so it was just kind of like, that was the most exciting. I kind of wanted to start off with a bang. And of course, speaking of starting off with a bang, Alan Stern is just a wonderful person to talk to, a dynamic personality. He's, just a wonderful, I've had the great pleasure of being able to interview him throughout the mission. I interviewed him back in, January of 2006, just months before the spacecraft launched, and we talked about the mission, and I interviewed him throughout the 9.5-year flight to Pluto, and then had the chance to talk with them after the mission as well. Well, I shouldn't say after the mission is still ongoing, but after the Pluto flyby. And so that was how I chose that one. Another, as far as the rest of the order, I don't know, it just kind of fell into place, I guess. I tried to, it's like all of them, all of these missions, got to hold a special place in my heart because I got to know the missions really well, and I got to talk to so many of the people behind the missions. And so it's like each of these missions are kind of very special to me. So their order in the book is by no means the order of the importance or anything like that. It's just, I don't know.
I was sitting there going, is it launch dates?
Yeah.
Is it what? So I figured you might have had a reason, and they're all interesting. So definitely there is nothing to the order as far as importance or interest or anything like that.
Yeah, right. And it was just, in writing the book, the big challenge in writing the book was an extremely short timeline of doing my interviews and having the first draft ready. I only had about 4.5 months. So
whoa. But
so
you have the context, so it's not
right.
like you're hunting who should I interview, right?
Yeah, all of the media relations people at the Jet Propulsion Laboratory and Johns Hopkins University and Goddard Space Flight Center, they were wonderful. I just, contact them and say, I'm writing a book on these missions, and I would like to talk to a couple scientists and a couple of engineers for each of the mission. So like, this was in December, and in January, the second week of January, I flew out to the Jet Propulsion Laboratory. They had 3 solid days of interviews lined up for me, and interspersed between the interviews, I got to go like to the Mars Yard out there, which is like their practice field, that they have these engineering versions of their rovers out there, and they can practice traversing across sand dunes or over rocks and that kind of thing. Got to see all the different, the rooms that you see, the mission control rooms that you see on, if you remember when the Curiosity rover landed, there's, all these people in blue shirts, monitoring these consoles. So I got to tour that room and see lots of all these places that I had, seen on NASA TV and all that sort of thing. So it was fun to be there, fun to have the opportunity to meet these people face to face and talk to them about their missions. And so I interviewed 37 NASA scientists and engineers for the book.
That's good.
And every interview was just so much fun and such a joy. They were very excited to share their stories of what it's like to work on these missions and how they came to be scientists and engineers, what inspired them. And just it was really fun. I enjoyed the interviews a lot, and then sitting down to write it, that's the hard part, but it was fun. It was fun to do.
You talked about it some in the book, and here you're talking about talking with these people. And one thing that is true about people who work on these NASA missions is that they are really into it.
Oh yeah.
Yeah. None of them are really just,
nobody phones it in. They're there, right?
They are doing it because they've got that space fever, and they want to do these things and do really good jobs usually.
Well, and you
Yeah,
have to want to, right? Because these missions
The
take a
commitment.
long time from inception
Yep.
to launch to, yeah. So why don't you tell us a bit about that?
oh,
Well,
sure. Yeah,
yeah.
that's exactly right. They're probably the biggest space nerds, and they're all fans of exploration and of space and of NASA, and so they know that they have these very unique and unusual jobs, and a lot of them know that know this, and they're very good about sharing. A lot of them have Twitter accounts, and they're kind of sharing things like, in particular, Carrie Bean, who works with the Dawn mission, and she also now works with some of the rover missions as well. And she's very good about kind of talking about what she does or what happened during the day on Twitter, and it's fun to follow her. And yeah, they were all wonderful people to talk with, and I not only got to talk to, like, Alan Stern, who's the principal investigator of the New Horizons missions. I got to talk to a lot of the principal investigators, but what was really fun was to talk to kind of some of the behind the scenes people. I talked to a large group of people from the Mars Reconnaissance Orbiter mission, and in particular the HiRISE camera, and what it's like to, yeah, you're working behind the scenes to figure out, how do you send the commands, or formulate the commands to send to a spacecraft to take a particular picture of a small little spot on Mars at a certain time under certain lighting conditions using certain filters. How do you program a spacecraft to do that, that's traveling at high speeds around a planet, and to take these absolutely stunning pictures of Mars and other worlds out there? It's to me, that's incredible.
Most of those people, the engineers that I've known, and that I want to have a similar topic that we've talked about, but even the ones behind the scenes, the guys doing the thermal analysis, the guy writing the algorithm for the camera, the woman doing this checkout over here, they've got that keen interest in space and exploration. But all the times I've seen, at least with successful missions, the mission also appreciates those people. They let them know that what you are doing is critical to making this mission happen. And so there's a whole management thing that it's hard to get a feel for, but where people's work is appreciated and they're doing it because they really want to. There's a lot of enthusiasm.
Oh, yeah. You talking about that reminded me of the interview I did with Earl Mays, who's the project manager for the Cassini mission. And, that mission has launched, let's see, when did it launch? 1999, I believe. And it got to Saturn in 2004. So that mission has been going on for a while, and it's going to be ending this year, sadly.
That's right.
But Earl was talking about kind of the whole cadre of scientists that they've had over the course of the mission. He said, we've brought on some younger scientists to kind of work in the shadow of the older scientists, and they've learned the ropes and have gone on to conquer other worlds, as he said, to go and work on other missions. And both him and Linda Spilker, who's the lead scientist for the mission, they just talked about the importance of the team of scientists that have worked together from around the world on this mission. That's kind of the thing with, even though they're classified as NASA missions, there's so much international cooperation on these missions, which I think can be a model for political cooperation. It would, I think, people could look at what's going on in space missions as far as how people could learn to cooperate better around the world.
And then also for people who don't know much, but there are lots of good things to know about NASA culture. I worked on a microgravity experiment that flew twice on the space shuttle in '94 and '96. And I started working on that when it was a laboratory idea 10 years before that. And we noted during the project that, along the way, before something launches, or even after you've launched and done mission operations, there are hundreds of people who get involved, and you get to know all of them. And it takes a long enough time that people get married, some people die. We've had that happen.
Yes.
A few babies were born. And so I thought it should have been, a flashing lights, but you wrote, getting a robotic spacecraft or a mission to space is no easy task. I want to hear more about that. I want people to understand that, yes, it takes a long time, and people want to try to do it in a shorter time, but I don't know whether we can get there from here yet.
Right, just kind of the way NASA chooses missions, and the what they have announcements of opportunity where specific types of missions are being looked at, and they'll encourage people to propose. So yeah, it can
in a very open process.
Right, exactly. So there can be, there are for every mission that goes to space, there are probably 10 other ones that are just as exciting and interesting that don't make the cut. And and it's just a factor of funding and availability and launch windows and all that kind of thing. But yeah, it's a long process of when you come up with the idea. There's probably some outstanding science question or some mystery that people want to answer, and they come up with an instrument or a spacecraft with multiple instruments to kind of solve this mystery or answer their questions. And so
I'm sorry, it can seem sort of trivial or arbitrary sometimes to say, oh, here's this mission which is going over to here, and they're going to drill and look at these rocks, and then they're going to do this spectrophotometry here. And people go, why are they doing that instead of? But what's behind that is probably 10 years of continual peer review, engineering review, people to decide, yes, this probably will give us the biggest payoff in science for something we can do, but we can learn something from putting this instrument on there too, and so it can advance the state of the art. That's part of the process. A lot goes into choosing to do these specific things in order to try to maximize what we learn, right?
Yeah, exactly. And they've all of the different instruments kind of, even though they're doing separate observations, a lot of times they have to work together as far as figuring out the timing. If all the instruments are kind of bolted on to the spacecraft, like most of them are now, the Voyager had kind of cameras that could slew from side to side, but that just got to be really expensive. So it's more cost effective to just bolt your instruments on. Well, then you have to turn your spacecraft so that this camera can observe this spot over here. And in the meantime, the other instruments are over here and can't do any observing. So they've had to learn how to kind of slice and dice their mission profile of getting everybody the opportunity to use their instruments at the optimal time. So that's another kind of cooperation thing that a lot of people could learn from of you've got a limited time. A lot of these missions have a limited time of when they're operational, or when they're doing their flyby, or when they're doing their mission. And so you've got to optimize every minute of these of when these spacecraft are available.
The mission planners are very adept at doing that. And I think you told some really interesting stories. I think it was with Cassini about coordinating all sorts of diverting things, and the scientists all working together, and you don't want to do certain things because it might have a higher probability of damaging a sensor. We'll do it, but we'll do it after we've done these other things.
Right.
And I liked, I was not aware of this, the story of the Cassini Huygens, where they were not able to communicate because they were going at the different speeds, and that created an issue. But then they figured out how to work that out.
Right, exactly. And I had knew there was this kind of problem with the Huygens spacecraft, which was a piggyback mission that went along with the Cassini spacecraft. And the idea was Huygens was going to land on Titan, Saturn's moon Titan. And there was a problem with the communication rate. And so they were doing a flyby of Earth to get a gravity assist to make it out to Saturn. And so they decided to do a test. And so they kind of simulated a test of the Huygens probe, making its descent down to Titan, and they didn't get any of the data. And anything that they got was garbled. And it took them several months to figure out what the problem was. And at first they just kind of said, you know, we're not going to have a mission. This isn't going to work, because you can if you can't send back your data, it doesn't matter how much data you've gathered if you can't, you know, relay it back to Earth. And so, well, they figured out the problem was in the communication between the Huygens spacecraft and the Cassini spacecraft, which was going to act as a relay. Because Huygens was a smaller spacecraft, didn't have the ability to transmit directly to Earth. So after some very high-powered engineering tests, they figured out all they needed to do was to change the way that Cassini was flying away from the Huygens probe. It's like just using kind of a different frequency in able to make the communications. So yeah, you know, you're doing this, you're figuring out how to fix a spacecraft from, you know, millions of miles away, and they did it, and it was a great success. That's a great story that was fun to tell.
With some amazing feats. Yeah,
I think there's a lot of tension in these stories.
Oh yeah.
Is it going to land, like the famous Curiosity situation? Is it going to land safely? Well, you know, or will we have launched something and it's not going to work? And of course, Hubble, you know, which required people and not just software tweaks, right? Right,
exactly. Yeah, Hubble's a great example of, you know, a lot of people say, you know, is it humans versus robots? Well, Hubble is a great example of humans and robots working together and learning how to fix problems and problem solve and you know, team efforts. It's all great examples of how the rest of us could cooperate together.
I was looking. This is I think a new topic, but you noted that Cassini lasted for 13 years around Saturn, and I know from the bit that I did with NASA, but all of these robotic missions usually have what's called their design lifetime, which people may not understand the implications. And it's usually something like 18 months, or something that, you know, matches the critical thing. And then there are extensions. And really, things tend to be designed for longer than that anyway, kind of. And sometimes they go along very long. And then I wanted to tie that in with, I thought, the very interesting observation when you were talking about the Mars Reconnaissance Orbiter, and I think the Lunar Reconnaissance Orbiter is another example of how people at NASA are starting to design long-term missions intentionally to last for 10 or 15 years, because that's sort of time scale they need. But it makes sense. How did we finally get from these, you know, 6-month missions that turn out to last 5 years to something that's actually designed to last for 15 years?
Well, probably the big thing is just the advancements in technology and computing power and those kind of things. You know, the first Mars rover, the Pathfinder rover, was projected to last, like, you know, maybe 2 weeks, but it did last about several months. So that was exciting. And of course, the Mars rover's Opportunity and Spirit, the design lifetime of about 3 months. Well, Opportunity still going. What are we, 11 years into the mission now? So yeah, it's I think, you know, NASA builds these very robust spacecraft, but they're also very cautious. I don't think they want to say, oh, this is going to last a long time and then it lasts 2 months. They like to underestimate and over deliver, I think, is what they like to do, and that's they've done that a lot. You know, missions like Cassini that have gone for so long, or the Mars rovers, and we can hope that the Curiosity rover lasts a long time as well. But even like the Voyagers, you know, we're still getting pings from them every week, and we know where they are, and they've even able to make discoveries about the outer part of our solar system because of their distance and how far they are away, and sending back the limited data that they can take right now. But still, we're making discoveries, and so that's exciting.
And speaking of the furthering missions, that there was originally, of course, the plan for the New Horizons to continue past Pluto but they've actually announced last night, like, this is what we're doing next.
Yeah.
And what do you know about that? Because you'll know more than I do.
Yeah, well, they actually announced like shortly after the flyby that, well, and NASA's real cautious about announcing that mission extensions, because you have to take the costs into mind, and hoping that the spacecraft survives the Pluto flyby. But shortly after the Pluto flyby, they announced that they were actually going to go, or NASA announced a mission extension that they could go and observe another Kuiper Belt object. A very different type of object. Pluto is kind of a bright, icy object, and they had discovered another object. It's got a very bland name of, I think it's 2014 MU69.
Yeah, it's something, I think I retweeted it, so I should go take a look
at
it.
So but anyway, so they've known that they're going to be heading towards this other object, a very different object. It's a darker object, a Kuiper Belt object, something that we've never had the chance to look at close up. And but now, last night, they announced they've been doing some observations with it. Kind of, they've used the Sophia airborne space, not spacecraft, but aircraft, to make observations, and also just some ground-based observations. There's been some occultations of this object where it goes behind another star, or I guess goes in front of another star, and you can kind of get some information about the object as it kind of goes in and out in front of another object. And there's now the possibility that this is a binary system, so it's like two objects instead of just one, which, two is better than one, so it's exciting.
Right, yeah, I could see that's the artist rendering.
Yeah.
Looks like they're so close together, but then they can be discerned to be two things. So.
Yeah, I mean, we found that a lot of asteroids are binary asteroids, where two are kind of orbiting each other around a common center of gravity, and finding a Kuiper Belt object like this, it might be the first Kuiper Belt object that we've known of that is a binary system. So, and that the spacecraft is going to be going and observing this one close up is pretty exciting.
Yeah, it is. It's amazing that, and it's good to see a mission extended like that to get more and more information.
Yeah, back to Jeff's comment about building robust spacecraft. So I was interviewed Alice Bowman, who's the kind of the mission operations manager of the New Horizons mission that flew past Pluto and now out to this other object, and they're hoping that the mission could go into the 2030s. They've got a nuclear power source, the RTGs, I can't remember what that stands for, but anyway, it's a nuclear power source, and so they're hoping that it can last that long, and if they get mission extensions, then they could go observe other objects as well. So yeah, we could learn a lot about the Kuiper Belt just from this one spacecraft.
Right, and I think one thing we get, I'll let you speak next, Jeff, really quick.
No, it's okay.
When I looked at reading through all these things, everything depended on different propulsion, different power sources, different, all of these considerations. And I thought it was interesting, the wide variety of things, that NASA scientists are trying to do that work well for their mission, right?
Right.
Like, so ion propulsion's working better for Dawn, right? And then different kinds of propulsion work better, to where do we have to go? What do we have to do, right? Very fascinating.
Yeah, it was fascinating to talk about the different systems. Ion propulsion, it's just such a great kind of a melding of science and science fiction, because it's, ion propulsion, we've heard about that in Star Wars and Star Trek, and multiple books have used ion propulsion in their sci-fi stories. But here's an actual mission that's using this, and very robust. The spacecraft was able to go to two different objects and go into orbit around two different objects, the first spacecraft to do such a thing, and just making science fiction and turning it into science fact.
I was evidently reading about this mission when I noted on page 94 in my copy of the book, no orbital dynamics drama for achieving orbit around Ceres or Vista. I'm not sure I remember what it was I just read before that. I thought, oh my goodness, all that orbital drama.
Oh yeah, well, remember, as you know, Joanne mentioned earlier, the excitement of the Curiosity rover landing.
Yeah,
you know,
I think.
everybody's sitting on the edge of their seat and wondering if this is going to land correctly, and then when they get the signal that the spacecraft has landed, everybody's jumping up and down and hugging and crying, and
Yes.
you know, and it was kind of a worldwide event that everybody was watching online, or at least everybody in my social media circles anyway. But then
yeah. You quoted someone as saying, "No minutes of terror."
Yes,
relates to that.
Yeah, Mark Raymond, who's one of the lead engineer for the Dawn mission. Yeah, he said when took several months to get into orbit and to slowly spiral down, and yeah, he was out dancing with his wife when it initially went into orbit, and you know, it's not a quick thing, it's a slow thing. So you know, acceleration with patience is how he described it.
This is versus with the rover landing, what, the 7 minutes of terror when things are happening and untried stuff is going on and they don't have communications. And I suppose there's a place for both of them, but I prefer the lower drama.
But we will have some excitement, right, when Cassini crash lands onto the surface of Saturn. But then that delay, that time delay, is even longer.
It's about a 90-minute delay of when the signal reaches Earth from when it happens, and it'll, you know, it's going to be all of a sudden we're not going to hear from it. Or it might be a gradual thing. You know, it's going to be sad when Cassini crash lands into Saturn, but they're doing it for a good cause. The spacecraft is running out of fuel, even though all the instruments seem to be working really well and the spacecraft is operating really well. It's been a very robust and problem-free mission, but they are running out of fuel, and so they won't be able to you know, guide the spacecraft or tell the spacecraft where to go. And there could be some microbes from Earth still adhering to the spacecraft. Microbes seem to be very robust and they can survive a lot of different things. So there's some potentially habitable moons around Saturn, and they don't want to contaminate them with any microbes or anything like that. So it's called Planetary Protection, and you've probably read in the news lately that NASA is looking for a new Planetary Protection officer, which is it's a great title. It would be great on your business card. But yeah, so it's actually a big part of missions these days. Is, you know, how do you make your, you know, all these spacecraft are built on Earth, but you need to kind of decontaminate them, but you don't want to wreck your instruments by, you know, putting them through, you know, like blasting them with radiation or something like that to get all the microbes off. So it's a fine balance.
This might be like our Jeopardy lightning round, but as I was reading, I wrote down a couple of startling facts, and I don't know if there's what there is to say about it, but things like things that we didn't know that we do now. 6% of all meteorites on Earth come from Vesta.
Right. And
how surprising is that? That's
what's
going on with that, you know?
That's amazing. And they all come from a certain spot on Vesta. So the Dawn mission has showed us that there's this huge impact crater on the south pole of Vesta. So it got slammed into by another object, you know, millions of years ago, and sent all this debris flying through space. And obviously it was just in the right trajectory that a lot of the meteorites that we have from Earth are from Vesta, and they're all from this South Pole basin that got slammed into millions of years ago.
That observation ties in, doesn't it, with something that was in the news in the last couple of weeks about going to visit or working with another asteroid, and some comment that some scientists think the asteroid might contain organic molecules. And people are like, why would they even say that? It's like, well, look at all this stuff that came from Vesta. If organic molecules are common in meteorites, they've been there for a long time, and some of them have gotten to Earth.
Right.
And there may be implications, right?
Yeah, there's, how did life start on Earth? People have wondered, was organic material brought to Earth from comets and asteroids, or is that ubiquitous throughout space? Do we have that type of material everywhere? So
that may be another thing that's becoming much more common than we used to think was possible, even to find organic molecules. They're finding it in interstellar dust. Amino acids and things like that. What about those bright spots on Ceres? What is a mystery with those? Do we know anything more about those yet?
Yeah, so there were these bright spots on Ceres, and even before the Dawn mission, there's been hint of those from like Hubble Space Telescope. But as the Dawn spacecraft got closer and closer to Ceres, these kind of bright spots were almost like beacons kind of shining on shining from Ceres. And of course there was all sorts of speculation, lights from alien cities or this kind of thing. Well, it turns out it's just salts, basically, kind of like Epsom soda or Epsom salts. So obviously though, but it's still exciting because obviously Ceres has a wet interior, or used to
there somehow.
So it's got water bubbling up from the surface, leaving these salts behind, these bright salts, and they're very reflective in sunlight, that kind of thing. So that's kind of why they were kind of shining.
Right.
But it's just all exciting, and
it's so weird.
Yes.
One that I think, and I think this was in relation to Kepler, but I'm not sure. But in March of 2016. That's the people, explorers, for the first time ever, we saw the shock breakout in a supernova event. I was excited by that. Was that Kepler? No.
Yes, it was. So now the Kepler mission is not, well, they still are looking for exoplanets, but they had a problem with the spacecraft. So in order to stare at a certain spot in space, you need to have a very stable spacecraft. And so you have these things called reaction wheels, which are basically kind of gyroscopes in the spacecraft. And the spacecraft has 4 of them. And in order for the mission to succeed, you need at least 3. And they lost 1, and then they lost another. So they only had 2. But they still had this great telescope out in space. And so, people came up with this great idea to have a different mission profile. And so they're able to do different things now. They're even able to make observations of the planets in our own solar system. They're looking for things like supernova. And they saw this kind of, as it happened, a supernova going off. And we
believe, astrophysicists believe they know, and it's a complicated series of events in a supernova. With this happens, then this happens, and this shrinks, and this happens, and these make these atoms. And at one point, there's that thing where this is collapsing so fast it creates a shock wave that comes out, and that was what was seen. And that's hard to catch because it happens in parts of a second.
You basically have to be looking at something by chance as it happens, and that's just what happened.
One of my other favorite little stories that we were talking about something earlier was there's a guy named Doug at Ball Aerospace who figured out how to use the solar panels, to orient them to get solar pressure, to use solar pressure to balance and compensate for the one reaction wheel that wasn't working on the Kepler mission.
Right. Yeah.
What a story.
That was a good story.
And it's just kind of as the one person that I talked to, Wesley Traub, who's head of NASA's exoplanet exploration missions, he said it was just like something that happens in a movie where the hero comes in and comes up with the MacGyver-like solution at the end and figures out how to make something work, and that's basically what happened.
And I've been there like a couple of times, but that's the time he says, wait a minute, what if? And everyone's listening. And then there's just silence. And everyone's thinking, yeah, that's obviously, some of those things just hit you in the face. Like,
it's so crazy it might work.
Yeah.
So crazy it might work. Yeah.
It's going to work.
So why don't we ask? We have a few minutes left, but I'm curious. First of all, to ask, how did you get into this job? How did you end up with the job you love so much? Like, you know, what's your story?
Oh, yeah. So this is kind of my second career. So I had my kids and stayed home with my kids for a while. But then when they went off to elementary school, I kind of rekindled my passion that I had with space exploration since I was a young girl. I'm old enough to remember the sitting down with my family and watching the Apollo missions, and I just was always fascinated by that and the Voyager missions and the first missions to explore our solar system. And I just kind of got like I said, excuse me, rekindled my passion about of space exploration. I was an English major and realized, hey, I could write about this stuff because there doesn't seem to be a lot of people following what's going on in space, all the exciting things that are happening, both human missions, the space shuttle program was going on at that time, and the robotic missions. And so I love to write, and I love space, so I kind of combined those two. And I worked at the Science Museum of Minnesota for a long time, or for a couple of years, and realized I could instead of just sharing all this stuff with kids, I could share it with adults too. So that's when I started writing. And then in 2004, Fraser Cain from University had published a little thing online saying, hey, I'm looking for some additional writers. And so I sent him my resume, and he promptly gave me a great assignment of writing about interviewing a former astronaut about going to Mars. So that was a fun first article, and it's been a great relationship ever since.
Wow, that's amazing. So
yeah, so it's I guess it's basically a story of following your passion and following your bliss and doing those kind of things that you probably I would have never imagined that I'd be doing this and having the opportunity to write a book and to talk with all these amazing people that I get to talk with.
Right,
okay,
and to go view some launches, etc. Right?
Yes, exactly. Yeah.
I do have one more little quotation that, Joanne, I was saving sort of for the end because it seems that sort of thing. You quoted Mark Raymar, who was associated with one of the projects, but I loved it when he said, "Who doesn't long to know the universe?"
Yep. Yeah, Mark Raymond is with the Dawn mission, and he's just a very passionate person, probably the most passionate person I've ever met. He's passionate both about life itself and space exploration. And he just, he said everybody who's ever had these feelings of wanting to go beyond the next horizon to see what's out there, that they're part of this mission and part of NASA's mission as well, of being able to participate and follow along with these missions so closely that, as we talked about earlier, NASA making that available, making data available readily and sharing so much of their exploration as it happens with people around the world.
Amazing. Yeah, exactly. Wistful imaginings of the universe, right?
Yeah, exactly. All that kind of Star Trek future of what the future could be like, and yeah, I think we're living that now. This great era of exploration.
Right. It's incredible. So before we sign off, was there a question we should have asked you that we didn't, or something you really feel like you need to tell our audience?
I guess so. Writing this book really was not my idea. So I was actually contacted by the publishing company, Page Street Publishing. They had an idea for the book, for a book about NASA's unmanned or robotic missions to space, and they contacted me and asked if I'd be interested in writing it. So I was extremely honored to get that phone call, that kind of phone call out of left field that you don't expect to get. And they were great to work with, and pretty much said, okay, go write the book. And they weren't like hanging over my shoulder and telling me how to write it. They just let me kind of write how I wanted to. And from the get-go, I knew that I wanted to share the stories of the people behind the mission, because even though these are unmanned spacecraft. There are still a lot of people involved.
That's right.
And behind every robot is a lot of human effort. And I wanted to tell the stories of that human effort.
Yeah, it was really enjoyable, and you all can enjoy it. So we want to thank Nancy for joining us and for writing her book, Incredible Stories from Space. And you can enjoy all these pictures all in one place versus trying to go through all of NASA's pages.
With lots of links at the end to the places you
That's right. That's right. And that is the one benefit with the ebook is you can link directly, right? But yes, recommended for further reading is.
Yep, and my favorite space books too are at the end there too. So yeah, it was fun to be able to share all of that.
It's excellent, excellent.
Well,
all right, Nancy, thank you so much for joining us, and thank you to our viewers for tuning in. And well, Nancy, I'll see you around on Twitter.
Sounds good. We'll keep in touch. That's for sure.
Okay. Thanks, Nancy.
Thank you so much. Bye-bye.
Bye, everybody.